Awesome. Welcome, everyone. My name is Dev DeVrad. I'm an Associate Dean of Admissions here at Reed College, and I will be moderating this session on computer science. I'm going to pass it over to our panelists to introduce themselves.
Hi, thanks very much. Hi, so I'm Erica Blum. I am an assistant professor here at Reed in the computer science department. This is my first year, so in a way, I'm new around here too, but I've loved it so far, and I think you will too. So I research cryptography and distributed consensus. And I suspect we're going to have opportunities to get more into that down the road. So I'll leave it at that for now. Throw it over to Adam.
Hi, I'm Adam Groce. I use he, him pronouns. I've been here a bit longer than Erica. I'm the department chair at the moment, but I also do cryptography research and data privacy, statistics, and some other related things.
Hey everyone, thanks for joining. My name is Sima. I'm a senior computer science major here at Reed. I'm also an international student, so if you have any questions about that, I'm happy to answer.
Okay, so I'm going to share my screen and some slides, and we'll talk a little bit about computer science, and then we will answer some questions. So I thought it would maybe be best to start with just a sort of general philosophical overview of what computer science at Reed is. So I guess the first thing I would say is that computer science at Reed is a serious, rigorous computer science program. We are very firmly of the belief that sort of nothing about being at a liberal arts college or being at Reed means that you shouldn't come away with a serious fundamental understanding of computer science at the end of your computer science degree. That said, we are also part of a broad liberal arts education. So we do not believe in an education that is focused only on sort of technical details of computer science. We want you to have a well-rounded education, a broad education, and to see connections between all of those different areas. To see connections between other classes you're taking and computer science and so forth. I'd also say that our sort of general philosophy is to sort of focus on true understanding of computer science. So we don't think of computer science as a thing you learn in order to go build software, though you often do that with it. We think of it as we approach it in the same way that like a physicist would approach the natural world. Computers and computation is a thing that's out there in the world. And if you want to understand it, there are all sorts of questions you naturally ask. And we approach it with that mindset, right? What do you need to know if you want to actually understand what computation is and what's going on with computers, right? And there's all sorts of questions you would ask. We are not looking for the fastest way to build a big flashy piece of software. We're looking to understand how all of those things work, so that you have the ability to actually interact with them at a fundamental level, improve them, really engage with the field. And I would say that in general, we, both as faculty and students, are sort of driven by this idea of curiosity and really wanting to understand things. So it often leads us to teach the same sort of things you would see anywhere else, but with a different sort of lens on them, with a different sort of motivation than you might get in some places.
Alrighty, so we have a few friendly faces I'm going to introduce you to, in addition to mine and Adam's and Sima's. So we have here Greg and Charlie and Jim, in addition to Adam and I, make up the full-time faculty in our department at the moment. And although I think Reed tends to attract in its faculty people who have a wide variety of interests and expertise and curiosity about a whole bunch of areas, we also each have our own sort of specific interests and expertises. And so between the five of us, Greg specializes in machine learning, programming languages, formal verification. As I mentioned a moment ago, mostly study cryptography, security, and consensus algorithms. Jim Fix is also interested in programming languages, parallel algorithms, and concurrency. Adam, somewhere closer on the spectrum to my interests, and also focuses on cryptography and private data analysis. And then Charlie works a lot with memory management, how data is actually stored in your computer, and figuring out how we can make use of emerging technologies with new effective algorithms. And so I'd say, yeah, this is by no means an exhaustive list, but it is maybe a few things that come to mind, or that we want to come to mind when you think of each of us. And certainly we teach students and advise theses every year on things that are outside of these exact specialties. But I think we view these as a few of the strengths or specific interests of folks in our department.
Yeah. So thought it might be good then to talk through sort of exactly what you would take as a computer science major at Reed, what your time here would look like. So everyone who's a CS student at Reed takes 5 core computer science classes. There's a CS 1 and 2 intro sequence that does a couple things. We begin with Python programming, and sort of CS1 is first and foremost a programming class. But even in the intro class, we want you to see programming as a tool for doing computer science rather than as the whole reason you learn computer science. So even in CS1, we start to get into a variety of sort of bigger ideas and appreciation for the field as a whole. All of that continues through CS2, where we program in other languages, get to more low-level things where you're a little closer to how the computer is physically operating. Everyone takes an algorithms course, a theory of computation course, computability and complexity, and a systems course when you talk about how you build sort of large systems in computers. Those are courses everyone takes. There's also a set of math requirements. So it turns out if you want to really understand how computers and computation work at a fundamental level, there's a certain amount of math you need to know. So there's 4 math classes that CS majors at Reed all take. I should note here, they start at calculus. You have to be able to start at calculus to come to Reed and do computer science. But yeah, so everyone takes those. And then you take 4 more electives. And these vary a lot in terms of what's offered. Every year we offer 5 or 6 of these, and we rotate them around. Most electives are not offered 2 years in a row, so that in your junior and senior year, when you're taking a bunch of electives, there's going to be a lot of options available to you. So these change and rotate, but what I put here is a list of things we've taught recently, not including special topics courses, which are sort of one-off courses, but we've taught a variety of those as well. And you can pick whatever 4 of these or more. Many of our students take significantly more electives than are required. You can pick whichever ones seem interesting to you, and you can sort of focus the major on the kind of stuff you're most interested in.
Yeah, so a big cornerstone of what makes up not only this computer science major, but any major you choose to pursue at Reed is the senior thesis. And so I have here a selection of different recent theses from our computer science students. You can see ranging everything from genetic algorithms to applying reinforcement learning for Pokemon AI, to text compression using natural language models. So our students do a really wide array of things with the senior thesis. And so I think as an example, right now, I'm advising 3 students who are working on theses. And between them, I think they pretty well span a lot of my interests and expertises. I have one person who's doing fairly applied work on how well code recommendation machine learning models are, how well are they able to output code that is secure and bug-free. Spoiler is, so far, they're not terribly good at that, but folks are studying the problem and working on some interventions to hopefully make it better. I have a student on sort of the other end of at least the spectrum that my interests cover, looking at some theoretical secret sharing. So this goes back to sort of deep questions in mathematics and computer science about how we can take a piece of information and split it up among a bunch of parties such that if they want to cooperate and put that information back together, they can recover the original secret. But any unauthorized or too small subset of them getting together should learn nothing about that original secret. You can kind of think of a scene you may have seen in the movies where in order to initialize the nuclear launch protocol, you need to have two people turning a key at the same time. It's a little bit similar where we're able to take some private information or information that we want to secure and split it among a bunch of shareholders. And then lastly, I have a student who's looking into how we can test for and ensure an interesting property in live consensus systems. So consensus system, I mentioned a little bit earlier, is sort of a catch-all term for when we have a bunch of computers and they're all interested in maintaining the same data, but we can't just sort of blindly or naively copy that data from machine to machine. At least if we ever want to be able to update it in the future, we're going to need a way for those computers to cross-check with each other and update each other as that data changes in order to stay on the same page. So this becomes a really complex and interesting problem. And to date, there are sort of a lot of algorithms and ways, techniques that we have for solving basic versions of this problem, but there are a lot of sort of nice to have properties that we're still figuring out how to embed into these systems. So that is what my student Maddie is working on. I think I'll leave that there as a sampler.
Okay, so then the last thing I wanted to do was sort of talk about interdisciplinary theses, or interdisciplinary majors, I should say. So this is a thing that's I think pretty unusual to read, where somewhere else you might sort of double major and complete a major in two different things. At Reed, what is more common is to create a major that brings together two different fields and is sort of focused on the intersection of those fields. So the most common one that people do with computer science is the math computer science interdisciplinary major. Part of that is that it doesn't differ a whole lot in requirements from the standard CS major, but it's meant for people who are more interested in the theory of computer science and the underlying mathematics. The only differences in terms of requirements is that you have to take either vector calculus or abstract algebra as an additional math class. And then your 4 electives, instead of being all computer science, are a mix of math and computer science electives. And you have more flexibility about what you take there. So if you're interested in that kind of thing, that's available to you. And I should say that this is the kind of thing where you might not really know if you're interested in it until you get deeper into studying it. You should not feel the need to know exactly what subfield of computer science you are interested in right now. I would encourage you to explore and take some classes and see what you find most interesting. But also, you can propose ad hoc interdisciplinary majors between computer science and any other department at the college. And this is done all the time. So recently we've had interdisciplinary majors with biology and physics and economics and linguistics and a variety of other things. Some very standard combinations, like people who are interested in computational biology, but also just, you know, any particular thing you want to do, right? If you're really interested in the sort of fundamental computation involved in effects you would use in digital photography or whatever, right? That you can do an interdisciplinary major that focuses on that connection between CS and something else. So again, that's not something to feel like you have to know now, but it's, I think, good to know that those options are available. So that's all we have for prepared presentation, and I'd love to answer questions.
Awesome. Thank you so much. That I for sure learned a lot there. Um, would you so starting with some of the questions that had submitted, would you be able to discuss some of the extracurricular computer science opportunities outside of the major? So are there any clubs, any student groups around computer science, maybe common internships that CS students have pursued?
I think maybe not to push Sima into the spotlight, but I think she may be uniquely qualified to speak to at least some of our student groups.
So we do have some student CS groups. We have a C-Star group, and I'm actually a part of it. And essentially what we do is we organize events for CS students to socialize and just like meet more people. And we do have them very frequently, and they're very popular. So I certainly, when I was just a sophomore, I met like a lot of CS students just through that group. Also, I can speak to internships. CS program doesn't like directly point you to like internships, but you can do research, and that's very available. And all of our professors, they usually take some students to like do research. And I know maybe Adam and Erica can speak more to that, but I personally did internships, and I personally think that it's possible to find them if you have some passion for like some applied software engineering sort of area, and it's accessible. It's just you would have to definitely do research on your own. But I would say if you're interested in like research or like more sort of theory level approach to CS, then our department provides a lot for that. And I think it's very unique in terms of I don't know if like a lot of other schools they have those opportunities. So yeah.
Yeah, I should say I don't mentally categorize internships in the same box as extracurriculars, but lots of our students do them. They're not on campus mostly, right? You go find it elsewhere. But yeah, they're very common generally over the summer. It's unusual to be doing one during the school year, but it does happen.
And what about study abroad? That's another question that we have. It looks like the department webpage mentions a study abroad program in Budapest and hints at others. Are there other examples of study abroad that CS students can pursue?
Yeah, so there's a standing program in Budapest where it's sort of like a sort of pre-cleared and discussed program. But students arrange study abroad programs all over the place. I was just talking to a student who plans to go to Scotland. Yeah, you can go all sorts of places. Someone's going, I think, to Argentina next year. Yeah, they happen all over the place.
Yeah, and I think on that subject, I've been hearing from folks in math and other departments as well that it sounds like there's a push right now to expand the number of places we have sort of these standing partnerships with. So I think both we have the support for the ones listed, as well as encourage folks to explore other options. And we're also, as I understand, adding to that list of sort of standing partnerships we have with other institutions.
Yeah, great. One of the hallmarks of being at a liberal arts institution, in particular, is this idea of community building. I know institutionally we do a really great job of building community through like the student life kind of perspective. Can you talk a little bit more about how do students build community in the CS department? And maybe even further developing on that point, you know, we teach a lot of our classes here at Reed, and sort of this conference model is what we call it, right? Really discussion-based model. Do we see that appearing in the CS major?
Yeah, so I guess I'll start with some of that, and then especially on the community stuff, maybe Sima has more to add. But yeah, I mean, the C-Star group that Sima talked about and other things are sort of the sort of formal thing that exists within computer science. But I would say there's a lot of informal things. I know that the students have a Discord server that I'm not invited to. And so there's a variety of things outside of sort of the formal official stuff. But the other thing I would say is that like one of the things about being at a small liberal arts college is that like your community is bigger than your department, and you do not have to be friends just with other computer science majors, and you are part of the broader Reed community, sort of separate from your major. The other question was about sort of teaching format and conference style and that sort of thing. And it really depends on the class. We have classes that work in all sorts of different ways. So some of our classes are sort of standard old-fashioned lecture in front of the room style classes, though I think to small classes where you get a lot of chance to ask questions and be involved, and it's a lot more interactive than you would imagine with those sorts of things. My ethics and public policy class is a conversational class where everyone sits around the table and talks through things together. And there's everything in between. There are flipped classes where you do problems together in the class and then sort of watch videos, and like what would have been your lecture you do for homework, and then you sort of get a lot of hands-on help and group work when you're doing what would otherwise have been your homework. So yeah, so the format varies a lot between classes.
I also wanted to add that at Reed, and I know it's not the case in like a lot of other more bigger schools, we have very small classes, and especially in CS, that's also true. And I also, during my time at Reed, I really enjoyed how accessible the professors were. Like literally just today, I was struggling with my deep learning homework, and the professor was like really approachable, and I was able to sort of get help. And there's office hours regularly that people come to, and it creates like a very welcoming environment where like a professor is like sort of in it with you and tries to help you. And I definitely found it really rewarding through my time here. And I also was able to find a lot of friends because the classes are smaller, and generally when you all have sort of a problem set or like some midterm, there's always like study groups, there's always like this sense of like everyone is in this together, and that's how you sort of make friends within the department. But I agree with Adam that it's also sort of easy, it's really easy to make friends outside, and it shouldn't be like, oh, I'm in CS so I shouldn't be talking to this person. Like, no, I think that it's very sort of encouraging to be able to talk with other majors, and it's normal. So yeah.
Yeah, sort of picking up on some of the same threads, I think something that I've really enjoyed is that all of the computer science faculty's offices are collected along sort of the same stretch of hallway where near where quite a few of the CS classes happen as well. So I love when students are like flooding by as class lets out and they wave and say hi and stick their head in and tell me about something that they just learned that they think is cool. I love like seeing clusters of folks by the whiteboard in the hall, like working on something neat. Typically when professors are in and have a minute to chat, we'll have our doors open. So just walking down the hall, I feel like you feel you feel present in the department in a way that I think is really nice.
Awesome, thank you. How many students would you say typically graduate with a CS degree or some sort of like CS interdisciplinary major um, on average at any given year?
Yeah, in recent years, it's been in the mid-20s, somewhere around 25, I think, per year.
Great. And talking about homework and sort of work outside of class, how much homework do computer science students usually how much can they usually expect?
Well, I think as on the faculty side of things, I'm usually aiming for something like if you're taking a full load of 4 classes and you imagine that your classes are taken up about 40 hours of your week, then once I subtract out the time that you're spending working on the class already by spending time in class, that leaves about 7 hours left over. And so that's like roughly a number I have in my mind, although it'll be less some weeks and more other weeks. But I think again, that's the target. So maybe Sima might be better positioned to say how well professors hit that target. And I'm sure it also varies pretty widely from class to class, professor to professor, or even over the semester, there will be some ebb and flow there.
Yeah, or even within the same homework will take different people very different amounts of time.
Sure, that's very true. We also generally have folks with wide variety of backgrounds, and something that feels intuitive to one person may not feel intuitive to someone else. So I'm always aware of the fact that just because student A said that they breezed through this doesn't mean I can assign twice as much next week and so on. So
Yeah, I would say it depends largely on your background and on the class you're taking. Like, for example, if you have background in programming, then it probably will be easier for you to complete, CS 121, which is our intro class homeworks. For me personally, like I had more programming background rather than like theory background, so I was really struggling in compatibility and complexity class. But a lot of people didn't struggle with that because it sort of came naturally to them. But to me, it was like a lot of learning. So it definitely depends on like your sort of background prior. But I would say that overall workload, I would say it's more than you would expect in other read majors, from what I've heard. But again, all dependent on where you're coming from, and there's always support. And like even if it feels like a lot, we have tutoring, we have study groups, we have office hours, we have a lot of support. So yeah.
And while we're talking about background, I think one thing that's important to say is that we work very hard at Reed to make sure that you do not need to know computer science before you get here in order to be a computer science major. Right? If you happen to know a bunch, then like the first course might feel easier to you. But we want to make sure that if you have just sort of, high school math and no other background, that you are able to pick up CS starting at Reed.
yeah, I'll definitely co-sign that. That's something that I consider pretty important to me. Whether it's because different folks have different things available and accessible to them in high school, to just you never thought about exploring it before, and now you want to. I'm someone who discovered passion for computer science partway through my undergraduate career, and it's pretty important to me that path is available for you all as well. So certainly we want folks to say, you know what, I haven't tried this before, but this is where it starts. I love that.
We have people who came to Reed thinking they were going to be English majors who are now almost done their PhDs in computer science. And we have people who come thinking they're going to be computer science majors who are now doing English, right? It is okay to not be sure what you are going to do, and it is okay to change your mind even if you think you are sure.
Great, thank you. I think kind of Erica, your last comment I think is a good segue to this next question. I know students at Reed come officially undeclared and don't declare an official major until the end of their second year. Um, but if a student knows they want to major in computer science, are they able to start taking those classes like right from the first year? And the opposite end of that question, maybe they don't know that they want to do computer science until partway through their second year. Is that then too late for them to start as a CS major?
Absolutely. I think I can start answering this question, and then I'll maybe hand the baton off to Adam. But I think definitely they can dive right in. Our first course of our intro sequence, 121, is offered each semester. So whenever you decide now is the time, it will be being offered. It can have high enrollment, so it is often a good idea to aim to try it out a little earlier than later, but it is offered each semester. And similarly, the math classes that sort of pave the way into the computer science major as well, those also get offered quite frequently. So definitely they can come in and get started right away. I think I'll pass the baton over to Adam for talking about sort of
Exactly
starting
yeah.
at a later point.
Yeah, so I mean, our general recommendation is that if you want to do computer science, you start right away. Generally 3 of your courses your first year will be for your major, sort of CS or math courses. They don't have to be, but that gives you lots of nice flexibility later in your schedule, and so it's nice. It is definitely possible to start the major fall of sophomore year. Pushing later than that starts to get tricky, but it depends on sort of exactly what you happen to take. Usually if you're deciding you want to switch to computer science, it's because you took a computer science course or something and find it interesting, in which case you already have a course or 2. So yeah, switching as a sophomore is very easy. Switching later than that starts to get tricky.
And I think Adam's point about flexibility tends to kind of hit the nail on the head compared to other like research-oriented universities or even some other liberal arts colleges. The actual number of classes required for the major is not terribly high. And so one of the main benefits I see is that folks who are starting early can sort of have a consistent number of other slots open to spend on electives or other things that catch their interest. So I would say that a big benefit I see for folks who are sort of taking the CS and math courses from the beginning is that their senior year, they have like more opportunities to take those electives outside of the department that they're excited about. But I would certainly say that just because that extra flexibility is nice doesn't mean that it's not possible to pack in more computer science and math towards your later years here.
Great, thank you. How does Reed's de-emphasis on letter grades, or sort of showing students their grades right off the bat, and sort of our de-emphasis of that process, how does that work within the computer science department?
It works pretty similarly to how it works in other departments. You get maybe a little more information than you might get in some, and that sort of if you take a test, you usually get a number back, right? Like you get sort of your score on that test or whatever it is. But yeah, they're not translated to letter grades. I think our students generally find out their letter grades at some point, especially because most of them are applying to internships or something over the summer and they need to get a transcript to do that. And so they'll see their letter grades. But you get a lot of comments that say sort of like, this is not great performance, or you're doing wonderfully in this class, or whatever it is. So you have some idea of how you're doing, even if you don't know the exact letter grade. And I think the main point of de-emphasizing the letter grade is just to make you more focused on actually understanding the material, right? Instead of doing the thing that sort of like short-term helps, right? Do the thing that actually makes you know what's going on and focus on actually learning things. And in the long term, that's actually better for your letter grades. And I don't know, maybe Sima, you might have something to.
I pretty much agree with what you said. I definitely like that we don't have the like great emphasis. And as I already mentioned, for me, it was really helpful to just come into professor's office and ask how I'm doing, sort of ask if I need to do more, or maybe like point to the areas of improvement where I can sort of learn more. And I found that helpful as well. And yeah, we do get a lot of feedback. So there's a thing called like 4-week, 8-week comments, I think, that you just get, and you see whether you're doing good or something bad is happening, and you will find out. So it's I didn't find it to be like an issue of any kind. Actually, I think I like that.
Yeah, I think to pick up on something that both Adam and Sima mentioned, like the de-emphasis on grades is not translate or does not come out as a lack of feedback. I think like I'm always giving feedback in terms of like, oh, this is exactly it, or like, oh, there's a slightly different way that I would phrase this, or there's one more step that you need in order to put all these pieces together. But just like always trying to reframe that conversation from a point value to like what was the misconception, or where is an area for improvement. And I think that's felt really rewarding. I feel like folks respond really well to it. And I think like coming in, I was sort of like, people told me that there's no grades at Reed, but I seem to be like grading things still. And so I went through some initial confusion, but have really grown to like the culture that we have, that where grades are not like a dirty secret. We're not intentionally trying to mislead or obscure that information, but we just genuinely think that they should come second behind you understanding clearly how well you're doing and how well you're grasping the information.
I love the way that you put that, and I am stealing that for future sessions. Erica, thank you so much. Do AP test scores have an effect on where students can begin on the CS pathway?
So they don't automatically place you out of anything, but we have a placement test that you can take over the summer. And depending on how that goes, you might be able to skip the first class. The bare minimum you need for the AP probably isn't quite enough to do that, but a lot of actual AP classes go a little beyond the bare minimum required for the test. So there are a handful of people each year who can skip the first class. We're also doing, we're trying a slightly new sort of self-paced version of the intro course next fall that will allow people to kind of breeze through portions of the material that they already know. So even if it doesn't sort of affect the exact which class you're registered for, it will affect your experience within the class if you know things, whether or not you take the AP formally or not.
And kind of bouncing off of that question, I was looking at reflecting on the requirements of the major, and you mentioned, Adam, that calculus is the minimum math. If a student took calculus in high school, already, or maybe took it like through a dual enrollment, like community college or other institution, do they need to retake calculus at Reed, or can they?
No. Generally, you can place out of calculus with a 5 on the AP, and in all sorts of other situations, you talk to the math department and they handle math placement. We don't make that decision, but it is very common for people to skip calculus.
Great. And then I know most classes at Reed are semester long. Would that be accurate to say of the computer science program as well?
Yeah, there can be very weird, unusual things once in a blue moon, but generally classes are a semester long.
Awesome. And then the next question, how frequently do the faculty extend the topics of interest or research that they're doing with students? And can you talk a little bit more about the collaboration between research with faculty and students?
Yeah, so all the time, constantly. So one thing is thesis, which is right, like can be on anything, and we frequently um, advise things that are not our research area when we're advising theses, because we don't have someone who's an expert in every subfield of computer science. but lots of them are in our research area and are directly related to our research, and many of them become publishable papers. So I've had multiple students publish their thesis work in real serious conferences. But then also we do lots of research over the summer with students. So, I mean, me and Erica are working with a handful of students this summer. I know Greg is working with students this summer. I know Charlie is working with students this summer. And that's pretty common and standard. I've done summer research in the past where I've done it joint with a statistician here, working on things that are sort of at the intersection of computer science and statistics. I've had outside collaborators involved in that research. We've had all sorts of cool publications. I took a couple students to London when we got a paper into the top, or sort of tied for top, computer security publication venue. Yeah, it's all sorts of research happens.
Sima, a question for you. You mentioned that you're a senior, is that correct?
Yeah.
Can you talk about what you're doing your thesis on?
So my thesis is actually interesting because I sort of well, one of my favorite programming languages is Swift, and I used it a lot for iOS development. And that was sort of my applied area that I was really interested in. I, through some external opportunities, got into Swift compiler and ended up being like an open source contributor. And so my thesis is on like a full scale feature that I've developed and proposed to the language. And it basically talks about how I came up with that idea, the process of sort of developing and shipping a feature to like a widely used programming language. Also, performance evaluation of the feature, and sort of how I went about implementing it. So my thesis advisor, he had background in industry where he worked on compilers. So he was interested in that area, and that's sort of what my thesis is about. And it is, I would say, maybe a bit unusual with Reed students, because it's more on the applied side, but still because that's basically a contribution to a compiler. It does touch into theory of how compilers work, and definitely the elective I've taken at Reed about compilers definitely helped me to understand those concepts more and sort of explore them and apply them in practice with my thesis. And I also really enjoy that it ended up being so influential because it's essentially everyone who's using that programming language can sort of use my feature. And for me, it's really important that it got so much exposure. So yeah, that's pretty much the overview.
Thank you. And what has your relationship been like with your advisor in this process? How often are you communicating and connecting with them? How often are they providing you with feedback? Do you mind expanding a little bit on that?
Yeah, so we have thesis meetings every week, and as I already mentioned, my situation was a bit unusual because I already came in sort of knowing what I'm going to do. I already had a formal proposal written to the programming language, and I came in and I sort of explained that I want to devote sort of a semester, 2 semesters long to sort of implement the feature, and he agreed to help me, and he was guiding me mostly through my progress. And I, as a person, I tend to be very sort of organized. So I basically came in with like a plan, or here's what I'm going to do. And he ended up sort of guiding me towards completing my thesis and suggested how to, evaluate performance. He also had some suggestions on the implementation details as well. So it was a very collaborative process. And I would also say, just sort of a piece of advice, it's okay to sort of be uncertain what your thesis will be about. And a lot of my friends didn't know what their thesis will be about. And you end up sort of find in that, or your advisor might have some topics that might interest you. And all the time, it's a very sort of collaborative process with your advisor, and it shouldn't feel as like a lot of pressure. It is sort of your own work that you're putting sort of all that you've learned into, but your advisor is always there to help you. And that was definitely the relationship with my advisor too, where I never felt like I'm lost or like I don't know what I'm doing. I always had the support, and I think that's great.
Awesome, thank you. Staying on sort of this topic of the thesis, for our faculty, if a student were to do some sort of an interdisciplinary major, with computer science and physics, for example, how might that thesis look? Are they sort of dipping into both, and what does the advising look like for that as well?
Yeah, so the thesis has to include material from both disciplines, and is often on a topic that's sort of in the intersection of those disciplines and very easily counts as including both. And there can be very different intersections depending on what you're interested in. So a CS physics thesis could be someone who's interested in the physical building of computers, and they might be interested in hardware and electronics and take sort of physics and CS courses that are focused on those things and do a thesis on that. They could be interested in quantum computing and take our quantum algorithms class and, not be so focused on hardware stuff. Or, right, it sort of entirely depends on what your interest is. But yeah, to do an interdisciplinary thesis, you have to be interested in something where the two fields come together. And then those are generally co-advised. So you have two advisors, one from each department, sometimes kind of working equally. Sometimes one of them will be sort of the primary advisor. But you have resources from both areas of expertise.
Great, thank you. Adam, you and Erica both talked about some of the research that you're doing over the summer, or projects you're doing over the summer with students. Can you elaborate a little bit more about what the projects are?
Yeah, so some of the details are sort of worked out collaboratively with the students over the summer, so we don't know exactly what the research question is going to be yet. But the general area is differential privacy. So if you imagine you have a data set that contains private information, so medical records, for example, or something like that. And there's data analysis you want to do on it. You want to run a machine learning algorithm. You want to see if smoking and cancer are correlated, or whatever it is you want to do. You need to access that data, and then you need to get results, and you need to release those publicly in a way that can't be used to violate the privacy of the people whose data is in the database. So we are looking at ways to do data analysis with that privacy protection in place.
Yeah, I think I'll hop on a thread that Adam mentioned there, which is that both with thesis and with other research opportunities, I think that we really avoid, or it would be very rare to have sort of a canned project where it's like, okay, I'm going to set the student at the start of this predefined path, and they're going to walk straight down the path towards the goal. I think we really like to involve the students in that process of finding the question that you're going to answer, and then how are we going to answer it, and all of the stuff that sort of makes up the research process, even if it's not as obvious or flashy at first as, the actual results you get out the other side. So I think a lot of the time that process will have like an idea of, okay, here are the things that I could sort of be a good trail guide for you about, and of those, where do you want to go exploring? So I think that's a common theme in thesis. And often with, say, summer research, we might have a more narrow or a more like guiding idea there. For example, we've sort of chosen this summer to focus on differential privacy, but within that, we still definitely want the students to be involved in the sort of pathfinding of, okay, we're in this cool, unexplored landscape. Where do we want to go exploring?
And how common is it for students to go on to graduate school for computer science? And what are some popular institutions where they go on to pursue this, or where have you seen Reed CS grads sort of take their education and run with it?
So going to grad school is very popular. Reed CS is very good preparation for going to grad school. This like really understanding what's going on sort of attitude toward computer science is exactly what people want when they're looking for graduate students. I don't know the sort of really like immediate statistics for the last year or two, but it's generally been in the like 25–30%, something like that range. Wildly higher than most places. Lots more people go to graduate school here, but I think that can get overstated. Like that wildly higher percentage is still way less than half. And still the most common thing for a Reed graduate to do is not to go to grad school, but to go get a tech job just like you would see anywhere else. So while we are a great place to go in order to end up in grad school, you should not feel like that's what everyone is going to be doing. It's a very common option, but it's not the main thing. But yeah, I think our students are all sort of thinking about whether they want to go to grad school in a way that at other places it might not occur to them to think about it. As far as where people go, all sorts of places. I mean, we're a small college, so we're not sending hundreds out, and I can't give you sort of like elaborate statistics, but off the top of my head, in recent years, we've sent people to UIUC, University of Illinois, to Cornell, or I guess he switched from, he was started at Cornell and then moved to Carnegie Mellon, got his PhD there. University of Maryland has a couple, Boston University has a couple, UPenn, I don't know. I mean, this is just who I'm remembering off the top of my head, but yeah, there's plenty of places.
And you mentioned that while a large majority, or I mean, while a good chunk of students do go on to grad school, a lot do go on to work in industry. Can you also provide some examples of where in industry they may go?
All sorts of places. I mean, any major tech company you name, we've sent someone there, sometimes multiple people, and we're not an old program. We've only been around as a major for about 5 years. But yeah, I mean, there's a couple Portland area startups that have decided they really like hiring Reedies who each have like a handful. But yeah, and then people just go all sorts of individual places. Like a lot of people end up at a company that they're the only Reedie who's at, and that's fine. Yeah, I don't know.
Yeah, I did some internships, and I did one at Ancestry. It's a DNA company, and then also one at Apple. And I'm also returning to Apple after graduation. And at Apple, I've met one person who used to be a Reedie, and he's graduated in 2011. And it was really nice to sort of talk with him and about her experience. But normally, well, I didn't really meet a lot of Reedies in other places I interned at, but there are people, and some of my friends, I know people who interned at Microsoft, and some other companies as well. And so internships exist, but you can also do research. It's basically you can do whatever you prefer.
Awesome. Okay. We are at the top of the hour, and I know that there are a few questions that we did not get to. So I am going to share I apparently can't type and multitask at the same time, so I'll do it afterwards. But I am going to share the admission inbox email. So if we weren't able to get to your questions, feel free to reach out to us and you'll be connected with your admissions counselor. And happy to get you some more information from there. But I want to say a huge shout out and a huge thank you to Adam, Seema, and Erica for taking time out of your evening today and helping us all learn a little bit more about the computer science program and tell us what we can expect in that major. To all the folks who are attending, thank you so much for taking the time to be here and getting to learn a little bit more about Reed and what makes our computer science program different. And you all have a great rest of your day. Thanks so much.